Good morning, students. Today we will be performing an experiment in medical microbiology, and the title of the experiment is estimation of glucose in urine sample. Now, why is it important for us to determine or to estimate the amount of glucose present in urine sample? Is the presence of glucose in urine sample a common thing? Is it seen for everybody? No. This happens only during certain medical conditions such as type 2 diabetes mellitus. Now, what is type 2 diabetes mellitus? This is a medical condition in which the pancreatic beta cells are definitely producing insulin, but this insulin is not being taken up by the other cells and tissues of the human body. Now, why does this happen? This happens because there are certain receptors known as insulin receptors which are present on all eukaryotic cells. If these insulin receptors are not functional, then they cannot take up insulin, and if insulin is not taken up, then a glucose transporting molecule, that is GLUT4, does not get activated. And if GLUT4 does not get activated, it cannot take up glucose from the blood into the cell. So this leads to, because of this, there is a condition wherein there is glucose that gets excreted in the urine. Now, for the estimation of glucose in urine, the principle that is followed, or the protocol that we follow, is a titration protocol. And this type of titration is called redox titration because it is based on the oxidation reduction reactions of the experiment or of glucose. Now, as we all know, glucose is a reducing sugar. Now, why do we call glucose as a reducing sugar? That is because there is a free aldehyde group which is present on the first carbon atom. And this presence of the free aldehyde group makes glucose a reducing sugar. The most important reagent that we will be utilizing, or the only reagent that we will utilize in this estimation, is Benedict's quantitative reagent. Now, this Benedict's reagent consists of potassium thiocyanate, copper sulfate and sodium citrate. Now, since glucose is a reducing sugar, this glucose can reduce the copper sulfate that is present in Benedict's reagent, and it can convert this copper sulfate into cuprous thiocyanate. And this cuprous thiocyanate precipitates out as a white precipitate or a white colored complex. So, by measuring the amount or by calculating the amount of precipitate formed, we can calculate the amount of glucose which might be present in the urine sample. Now, let us move on to the protocol or the procedure for the experiment. This is a very simple experiment wherein we follow titration. We will first take 10 ml of Benedict's quantitative reagent. BQR stands for Benedict's quantitative reagent in a conical flask. And to this we will add 2 grams of sodium carbonate. Now, why are we adding sodium carbonate? Sodium carbonate here is serving 2 purposes. The first one is that it maintains alkaline conditions, which is very much necessary for redox reactions to take place. Second reason why we use sodium carbonate is that the sodium carbonate prevents the copper ions from getting deteriorated. Now, once we have added 2 grams of sodium carbonate, we will titrate this solution that is present in the conical flask, that is your Benedict's quantitative reagent, against the urine sample which is taken in a burette. Please remember, during the process of titration, the solution has to be constantly boiled. Once the experiment is going on, a milky white precipitate gets formed, as was explained in the principle here. The formation of cuprous thiocyanate gives rise to the formation of a white precipitate, and the formation of this white precipitate indicates your end point. Now, once this is done, you have to note down the readings of the burette, and the experiment has to be performed till you obtain concordant values.
Now, let us begin the performance of the experiment. As we have told previously, the requirements for this experiment are Benedict's reagent. It is written here that the reagent is quantitative. Please be sure to use the quantitative reagent and not the qualitative reagent. So we have the Benedict's quantitative reagent or BQR. We have a conical flask into which we will be pipetting out 10 ml of this reagent. We have also previously weighed 2 grams of sodium carbonate and kept it ready. Then we have a burner to provide constant boiling to the conical flask, and we also have the burette in which the urine sample is filled. So the first step now is to pipette out 10 ml of Benedict's quantitative reagent into the conical flask. The presence of copper sulfate gives a blue color to the Benedict's reagent. We have now added 10 ml of Benedict's quantitative reagent to our conical flask. The next step is to add 2 grams of sodium carbonate to this conical flask. We have already weighed 2 grams of sodium carbonate and kept it ready with us. Now we are going to add it. Now we will titrate this against the urine sample which has been taken in the burette by supplying or providing constant heat to the conical flask. We have to wait for the solution in the conical flask to boil. You can now see that the solution is boiling. This is when we will start titration against urine sample which is in the burette. The titration is continued till a white precipitate is obtained. So the drops are added one after one until we get a white precipitate. You can see that the color is changing. The solution has become cloudy. We will now again boil the solution. It is very important to titrate only under boiling conditions. Now we will titrate again till we get the white precipitate. The color is already changing, so maybe by adding another drop or two we should be able to obtain the white precipitate. So now you can see that the white precipitate has been formed. And you have to simultaneously note down the reading of the burette. The burette reading is 6.4 ml. The titration process has to be repeated until you get concordant values.
So dear students, we have performed the experiment, that is the titration, until we get concordant values, and the values have been tabulated in the tabular column. Now once the values have been tabulated, the next step is to estimate the amount of glucose that is present in the given urine sample. So there are a set of calculations for the same, and we will try to learn the calculations in detail. So the titration value that we obtained after the performance of the experiment was 6.4 ml. Now there is a standard statement which is universally accepted, and that statement is as follows. It says that 10 ml of the Benedict's reagent is reduced by 20 milligrams of glucose. So this is a standard that is accepted globally. Any institution, any laboratory that you go will follow this rule. So this rule states that 10 ml of Benedict's reagent is reduced by 20 milligrams of glucose. And from this statement we can tell that 10 ml of Benedict's reagent is equivalent to 20 milligrams of glucose. Now from the experiment that we performed, we obtained, or we have seen that 6.4 ml of urine can reduce 10 ml of Benedict's quantitative reagent. So from this we can conclude that 6.4 ml of the urine sample contains 20 milligrams of glucose. So if 6.4 ml contains 20 mg of glucose, then how many milligrams of glucose are present in 1 ml? So for this we just cross multiply and get the answer as 3.5 3.125 milligrams. So there are 3.125 milligrams of glucose which are present in 1 ml of the urine sample. So when we represent or when we perform any experiment, we generally represent the values in terms of 100 ml or in terms of 1 liter. Since 1 liter of urine is too huge a volume to estimate, we will stick on to estimating the amount of glucose which is present in 100 ml of the urine sample. So if we multiply this value with 100, we will be able to obtain the amount of glucose that is present in 100 ml of the urine sample. So accordingly, the milligrams or the amount of glucose present in 100 ml of urine sample is 312.5 milligrams. So we have since milligrams is not the SI unit for mass, we have to convert it into the SI unit, that will be grams. So when we convert 312.5 milligrams into grams, the answer obtained will be 0.312 grams, and this 0.312 grams of glucose is present in 100 ml of the urine sample. Since the calculation has been done for 100 ml, we can represent this as percentage. So the percentage of glucose that is present in the given urine sample is 0.3%. Thank you.